Hello everyone. Today the lesson that we will be discussing is shaping Earth's surface, including mountain, volcanoes, and earthquake formation. The topic is very interesting because it affects humanity. It affects our existence. Can you imagine that the ground that we're standing on is alive? It's moving. It's not still. We know that the Earth moves, it rotates. However, the ground that we're standing on is actually moving. This poster depicts three natural disasters that occurs due to changes or movement of the earth. First picture on the left, you see volcanoes formation. The second in the middle, you will see earthquakes. Third, last picture on the right is tsunami formation or occurrence. So the main objective of our lesson is to understand the structure of the Earth, identify and explain tectonic plate movement, which is very important as it explains how these natural disasters occur, discuss the causes and effects of volcanic formation, identify or list the types of volcanoes, explain the causes and effects of earthquake formation, and finally determine the strength of earthquakes. So I would like you to now take out the handout you have in front of you, which is the KWL chart. The first column, which is the what I know about this topic. And the second column is what I would like to know or what I wonder. I would like you to fill out the first two columns of this handout. Just take 5 minutes. Let's brainstorm and fill out the first two columns together. What do you know about this topic? Do you know what are volcanoes? Yes. Do you know what comes out of a volcano when it erupts? Yes, I hear some said magma, some said lava. We will explain the difference between the two. Does anyone know famous mountains? Mount Himalayas, Mount Everest, okay? Anything else you would like to add? Okay, let's move on to the second column, which is what I wonder or what I would like to know about this topic. What would you like to know? How volcanoes are formed, how the earth crust moves, yes. What else? You would like to know how mountains are formed, or examples of mountains, how earthquakes are formed, how earthquakes are measured. Excellent, okay. We will discuss each in moments. And the third column is what I learned. I want you to leave it blank and we will fill out this last column at the end of our lesson. So let's now watch this introductory video on this topic. It's very interesting. It will take 5 minutes. I want you to take notes while watching this video and listening to it carefully. And we will then start discussing and explaining our lesson. So, what is our Earth made of? Can anyone guess what's the first layer that we stand on? Yes, the first layer is called the Earth crust. And this layer, which is in the gray part, first layer, gray color, it is a thick, solid layer. Its thickness varies from node or 0 to 60 kilometers. It is not a single layer. It is made up of pieces, like pieces of puzzles connected together or linked together. So it's not just a single layer. It's a layer which is thick, solid. However, it's pieces connected together. Okay, let's see the second layer in the orange part. It is called the mantle. The mantle is approximately 2,897 kilometers in thickness, and this is where all the action takes place that causes the Earth crust to move. it contains what is called the molten rock or magma. Yes, you've mentioned magma before. It is what erupts out of a volcano, but we will say the difference later between magma and lava. So the mantle is the second layer, which contains the magma. The third layer, which is in the lighter orange color, is called the outer core. And here the temperature is very high. It contains minerals like nickel and iron. These metals are liquid because of the high temperature. The fourth layer is the inner core, which is in the yellow part. And in this layer, the temperature exceeds thousands of degrees Celsius, more or over 5,000 degrees Celsius. So it's very, very hot, extremely hot. And here also the pressure is very high. This layer also contains iron and nickel. However, they are not in a liquid state. They are in a solid state. Can you guess why they are in a solid state? Although the temperature is very high, they might melt, or they should melt. It's because due to the high pressure, exceeding the high pressure in this area, the iron and nickel remains solid because of the pressure inside, the very high pressure inside. So what are plate tectonics? Remember, we mentioned a minute ago that the Earth crust is not just a single layer. It's pieces of puzzle linked together. So as you can see in the diagram, so it's like a map of the Earth. You have the continents, the African, the North American, Eurasian, the Arabian, Australian. So these are all the continents within the plates. So the plates are connected together by plate boundaries. You see the plate boundaries, like between the brown and green color, this line in between is called the plate boundary. So when they are connected together at the plate boundaries, they move or collide. This movement is called plate tectonics. So what causes these plates to move? How do they move? They move due to the pressure and temperature difference within the second layer of the Earth, which is called the mantle. Remember, we said the mantle is where the action takes place. So the mantle temperature is high, the Earth crust temperature is lower. So what happens in the mantle is the molten rock solid called magma, it melts, becomes less dense due to high temperature. It moves up, as you know, less dense moves up. This movement up causes it to cool down because the Earth crust is cooler. Once it cools down, it goes back down again. So this change in pressure causes convection current. This convection current causes the upper crust, which is called the lithosphere, to move. So the upper lithosphere moved due to convection current or change in temperature and pressure. Again, the magma melts, becomes less dense, moves up, and then goes back down again. So it moves up to the lithosphere and it goes back down into the asthenosphere. The asthenosphere is the upper part of the mantle, the second layer, while the lithosphere is the crust, the Earth crust, the outer layer. Remember, these terms are very important. So how do you think volcanoes are formed? The change in temperature and pressure inside the Earth causes the molten rock magma to rise or erupt through the Earth crust. When the Earth crust is weak, the magma, due to the pressure inside, it melts and it moves upward in weak points in the Earth crust. erupting due to the high pressure, which happens during the plate movement when they collide. We will explain more in details how the volcanoes are formed in the next slides. So the plate boundary movement, or the movement of the tectonic plates, caused the volcanoes to form, and it causes also other natural phenomena to occur like earthquakes. How does this movement take place? According to the wave the tectonic plates collide. They move in a divergent way, or in a convergent way, or in a transform way. The first wave movement is called the divergent wave movement. As it is named, diverge. They diverge away from each other. The plates move away from each other. They separate. During this separation, mountains might be formed and earthquakes might take place. And also volcanoes might take place because of the weak points that occur between these two boundaries when they move away from each other. The second way of plate boundary movement is called the convergent way. So what happens during the convergent plate boundary movement is that the plates move towards each other. They collide, causing fold mountains to form. So when the mountains, they form, pressure inside the mountain or the molten rock due to high temperature and pressure erupts through weak points in the crust, causes volcano to form. The third way of tectonic plate movement is called transform boundary movement, when they slide past each other. The plate boundaries slide past each other. This sliding past each other causes earthquakes to form. Let's take an example of a divergent boundary movement. This is actually a headline taken from the news about Iceland. What happened in Iceland was tectonic plate movement between the Eurasian and the North American plates. Drifting caused drifting apart, or divergent movement in opposite direction caused earthquakes. Let's read the headline together. Why Iceland is being torn apart. Tectonic plates drifting in opposite directions cause 500 earthquakes a week. So can you imagine? 500 earthquakes a week was recorded when tectonic plates drifted apart in Iceland. So they drifted apart at a rate of 2.5 centimeters per year. So over years, these 2.5 centimeters could cause earthquakes